we define for resistor, the thing is like phase difference, am I right? Phase difference when we compare current and voltage. Phase difference when we compare input voltage, output voltage. Okay, input voltage, output current. Okay, how to handle those phase difference in the AC circuit? Usually sinusoidal input. Okay, how to handle those phase difference? Okay, if you have resistor, capacitor, inductor, and all. Okay, I mean, I think I built the theory. I even wrote one lecture note. That lecture note is to explain why we landed on that complex algebra technique actually. Okay, the same thing. This is not much different from our optics in case of optic or EM wave. Okay, we made a complex amplitude. Am I right? We kept the phase factor along with amplitude. Okay, it's not much different from that one. It's almost same. The math is same actually. Okay, fine. So I mean, while superposing wave, okay, we are going to use a complex what you call wave function. Am I right? Hmm? And I mean that made the math simple. Okay, how to handle that one? By defining these complex impedances. Hmm? That will fix almost everything. Okay, and you should learn that one. Okay, how to use that one. Okay, you have a resistor. Okay, that resistor. Okay, for AC circuit we write ZR. The ZR is simply R because current through resistor, voltage across resistor do not have any phase lag or lead. Do not have any phase difference. They will be in phase. Okay, fine. Then for capacitance. Okay, but how to use that one, that you should know. How to use this complex quantity to find phase lag lead, that you should understand. Okay, fine. ZC, okay. Resistor of resistance R, capacitor of capacitance C, ZC, that is minus J by omega C. Why? How that minus J appeared? Because I think, what is that? Voltage was leading or lagging? Leading. Voltage was lagging. Capacitor, voltage was lagging. Okay, fine. Minus J by omega. They can throw very basic question. Okay, you got a point. Now I'm thinking about building this one and going to much more sub circuit actually, but you understand the basic question. Okay, what happens in pure capacitor, inductor, RL, RC circuit and all. Okay, fine. So then inductor. Inductor of inductance L. What is this one? ZL, that's equal to minus sorry, J omega into L. Here current lag, voltage leads actually. Okay, fine. So these things will help us to what you call do anything actually. Okay, fine. That's the basic idea. Okay, or if you write here current and voltage. Okay, current through resistor, uh, voltage across resistor. That's equal to ZR into current through resistor. They will be in phase. Hmm? So what is this one? Voltage across capacitor. That's equal to ZC into current through capacitor. Okay, minus J, it will rotate this vector. Am I right? Complex algebra. Okay, if you have one real number, if you take IC along real axis, okay, VC will be along negative imaginary axis. Okay, that's how it will take care. Okay, fine. So then what is this one? Voltage across inductor, that's related to current through the inductor by ZL. Okay, IL. L means inductor here. Okay, fine. You got my point? So this is real axis. Okay, imaginary axis. Okay, fine. What is this one? Usually in this kind of circuit, I'll take current along real axis. Okay, then I'll check where is the voltage. That will give me leading lagging. Okay, fine. This is my IR. Okay, fine. My VR is also here only. Is that okay? VR is also here only. Okay, they will be in phase actually. Okay, fine. See this one. Then if I go to okay capacitor circuit, anyone on Google Meet?
Yes, sir.
Yeah, fine. Suppose this is my IC. Okay, then because of minus J, am I right? Real number multiplied with minus J. Minus J means minus of root of minus. So it will come to negative imaginary axis. Okay, fine. So later I will use this one. Okay, what is this one? VC. That's why voltage lags actually. Am I right? We say like this. Okay, fine. Lags by 90 degree. Okay, fine. So then next one. What is this one? IL, current through inductor. Okay, and voltage across inductor. Fine. That okay, because J, am I right? If you have a real number, if you multiply with J, it will become purely imaginary number. positive imaginary. There is nothing like positive or negative imaginary number in the positive axis of imaginary axis. Okay, fine. Real, imaginary. You got my logic? Okay, fine. Now, when you have series circuit, okay, when you have series circuit, okay, when you have a series circuit, okay, Z1, Z2, Z3, whatever, okay, fine. You can apply this one for series LCR circuit also. Fine. If you have series circuit, okay, fine. Suppose you have A here, B here, A here, B here, okay. Whatever may be the component, Z1, Z2, okay, Z3, okay, whatever may be the component, okay. Current is common, am I right? Current is common, okay. So that's why let us take current along real axis. Let us check where is the voltage. Okay, that's the logic. Okay, fine. So that's why I can write this is V1, V2, okay, V3, okay, voltage across VAB, that's equal to simply V1 plus V2 plus V3. Okay, fine. I can write like this. Okay, that VAB, that's equal to V1 is IZ1, IZ2, IZ3. I can be taken outside. Z1 plus Z2 plus Z3. Okay, fine, into I actually. I'll take this one along real axis. I'll check where this one is. Okay, where this complex number is. That will give me the phase difference. Am I right? So that's the basic idea. Okay, so that we call it as Z total. Am I right? VAB. Okay, total potential difference. Z total into I. Am I right? Series impedances are adding. Okay, can I say like this? Okay, fine. Now what I'm saying is this Z total. Okay, to quickly find phase lead or lag. Okay, I don't have to do everything. I just have to analyze. I just have to write this Z total. Okay, as mod of Z total into e power I phi argon representation. Then if you take this one along real axis, okay, so this will this where this vector will be, that is decided by that phi actually. You got to find. You can quickly do that argon representation where phi is, again, if you write Z as real part plus J into imaginary part, what is the tan inverse of imaginary by real? You got to find. So if you write Z total as A plus IB or JB, phi is nothing but tan inverse of B by A, okay, imaginary part by real part. Okay, that's quick actually. Okay, is that okay? So what I'm saying here is, okay, if I take this is my real axis, imaginary axis. Okay, if I take my current along in the series circuit, this is what I prefer. I'll take current along real axis. Okay, fine. Then if current is also real, okay, if you go with argon representation VAB, okay, that's equal to mod Z total. Okay, into I is also real, mod is also real. Okay, into e power I phi. Am I right? Is that okay? Now location of VAB, that is decided by e power I phi, isn't it? You got to find. Now this will be your VAB. You got to find VAB. Okay, fine. This will be phi, either plus phi or minus phi. Okay, that doesn't matter. What do you say? You got this math. Okay, current I'll take real. Okay, then this complex quantity that will have that argon representation, isn't it? So that's why that phi is the phase difference, lead or lag, you decide. Okay, depending on whether positive or negative. Okay, if you have parallel circuit, okay, fine. If you have parallel circuit, how to draw? Z1, Z2, Z3. This is the general idea. Okay, let me go to problem quickly. Okay, A here. Okay, B here. Okay, in the parallel circuit. Okay, currents are different. Am I right? I1, I2, I3. It's not comfortable to take current along real axis. You look at here, we took kind of real axis as a reference, am I right? With respect to that one, we are measuring the phase lead lag. Okay, that is the logic I'm using. Okay, so here, better to take voltage as a reference, am I right? Real axis, along real axis, because voltages are same actually, isn't it? So that's why if you have a parallel circuit, okay, fine, then this VAB, okay, whatever, yeah, this, what I will do is, okay, I'll add the current first, okay, what is the main current? Main current is equal to I1 plus I2 plus I3, okay, fine. So that is nothing but, what is I? V1 by Z1 plus V2 by Z2 plus V3 by Z3, but V is same, am I right? V1, V2, V3 same as VAB, am I right? You got a point. 1 by Z1 plus 1 by Z2 plus 1 by Z3 into VAB. Okay, fine. See this one. Here, it's better to take that VAB along real axis. Okay, and then where the current is. Okay, fine. Or you can do ulta. I mean, even though you take it into left hand side and take current along real axis VAB, you can locate that one. Both are same actually. Okay, it is handling everything. Okay, this complex thing that is handling it. I is equal to, can I say 1 by Z total? Am I right? We say like this. VAB, parallel impedances, just like parallel resistors. Okay, fine. But what I'm saying is why I want to take VAB, because that VAB is same as V1, V2, V3. Am I right? Hmm? So then what you can do is you can compare I1 and VAB, I2 and VAB, I3 and VAB, okay, individually. Okay, fine. Here I1, I2, I3, they need not be in phase. Hmm? They need not be in phase. Okay, fine. So that's why they can ask any tricky questions here. Okay, what is the phase difference between any of them? Okay, that you should be able to handle. Is that okay? Hmm? Suppose if they ask what is the phase difference between I1 and I2, how do you handle I1 and I2? Hmm. V1 equal to V2, am I right? V1 is I into Z1 is equal to I1 into Z1, I2 into Z2. Is that right? Hmm? Now what I need? I2 is equal to Z1 by Z2 into I1. I'll take I1 along real axis. I'll check where is this complex number. You got it? Like that. Anything you should be able to do one complex algebra. Okay, fine. So shall I move on? Now again, even in the op amp also, okay, op amp negative feedback, whatever you take, okay, the same idea works. Okay, what is this one? Minus plus. Okay, our suppose inverting amplifier V in, okay, Z1. Okay, we used to write ZF here. Okay, are you guys with me on Google Meet?
Yes, sir.
Hmm? Then inverting amplifier, what we have written? Output by input, that's equal to minus ZF by Z1 actually. Okay. Actual their RMS or peak value, they are related modulus of this one. But this complex relation that will tell you, okay, so V naught, okay, minus ZF by Z1, okay, into V in. If I take V in along real axis, where is this complex number, including negative sign? Negative sign also part of that complex number. That will decide what is the phase lead or lag. You got a point. But their RMS values, okay, we say what is that peak value, okay, V naught peak value, that's equal to mod of ZF by Z1 into V in peak value. Peak value or RMS value, they are related by this one. Okay, but if one goes to peak, other need not to go to peak at the same moment. Okay, that is handled by this complex number. Okay, you got a point. Now you have to just write the argon representation of this one. You got a point. Minus z, this one you just write a plus ib. Okay, you define tan phi. Assume v in along real axis, check where is v naught. Okay, fine, pure complex algebra. Okay, fine. So you can do these things. Non-inverting also. Okay, non-inverting also. Okay, fine. This was grounded. This was, here V in is given. What is this one? 1 plus ZF by Z1. Okay. The same logic works. You got my point? While finding their peak value relation, you use the modulus. Okay, fine. V naught peak value divided by V in peak value. That I think we define it as gain actually. Okay, fine. This one we define it as gain for this AC circuit. Okay, fine. So this will carry the phase information. Okay, V naught is equal to 1 plus ZF by Z1 into V in. Okay, fine. This is mod of 1 plus ZF by Z1. You got it? Fine. That peak or RMS values are related like this, but if one goes to peak, other need not to go to peak at the same moment. Phase relations are given by this. Okay, fine. So you just have to write argon representation of this one, A plus IB, R E4 I5. Okay, fine. So then that phi will decide. If you take V in along real axis, where is V naught? That is decided by phi. We need only phi. Okay, fine. See this one, or sometime gain. Okay, gain related questions are there. Okay, fine. I think I better to go to problem. I'll pick some JAM question, then gate question. Okay. Both in both exams they're asking this one. Okay. Let's start with one very simple one. So grab the general idea. Okay. So that you can solve most of the varieties of problem. You got a point. So that's why I have just discussed very general idea. Okay, fine. So that you can current, voltage, okay, voltage, whatever if you wish to compare, okay, you should be able to do that one. Okay, fine. That peak values or RMS values are related by modulus part. Okay, grab that one. Okay, let me start with this one, very simple one. Okay, the phase difference between input and output voltage of following circuit 1 and 2. 1 and 2 respectively. Okay, fine. One first circuit, both capacitor, second circuit, resistance and capacitance. Okay, fine. You see this one in the first circuit. Fine. In the first circuit, okay, VI, capacitance. One more capacitance. I'll say suppose this is Z1, this is Z2. Both have same capacitance. Okay, fine. Then this is output voltage. Okay. Now you can apply your potential divider formula. I think I did that one during filter circuit. Okay, fine. When I used to discuss filter circuit, okay, voltage across some output. Okay, that I have used potential divider formula. This V naught, okay, is nothing but impedance in that arm. Am I right? A main voltage, okay, main voltage into impedance in that arm divided by sum of impedances. That's quick actually. You got a point. Voltage divider formula. Okay, think like these are impedance. Fine. What do you say? Okay. Then you just check this one. Okay, V naught. Both are capacitor of the same capacitor. Minus J by omega C divided by minus J by omega C minus J by omega C minus 2J by omega C into Vi. What is this one? This is real. Real and positive. Negative value, that will have 180-degree phase shift. Okay, fine. This is real and positive. V naught is equal to plus 1 by 2. Am I right? Into Vi. They are in phase with each other. Is that okay? They are in phase with each other. Okay, you got my point? I hope I don't have to do further. Okay, if I take Vi along real axis, V naught also goes to real axis. You got my point? That's what we say, phasor or something. Okay, fine. Real axis, imaginary axis. Okay, if you take Vi here, so your V naught also half of that one. Am I right? Fine. You got a point. What do you say? So then next one, resistance and capacitance. I think that's one of the filter circuit. Am I right? Resistor here, capacitor here. What kind of filter it is? Low pass or high pass? Low pass. V naught. Okay. R C here. Okay. I'll say Z1 or ZR, ZC. Fine. VI. Again, I'll apply potential divider formula. Okay. Output voltage is nothing but voltage across this capacitor. That's equal to main voltage VI. You got a point. Main voltage into impedance in the same R, ZC, divided by sum of impedances, ZR plus ZC. Okay, now you may need to do some complex algebra here. What is this one? Minus J by omega C divided by R minus J by omega C into VI. What we do? I want to write this one as A plus IB. Now I can eliminate option, I think. Okay, fine. See this one. Okay, you got a point. Minus J by omega C divided by R minus J by omega C into R plus J by omega C divided by R plus J by omega C. Am I right? That's what we do. Fine. While writing this one, the whole complex number, we should able to write in terms of A plus IB so that we can find the phase factor. Okay, fine. So this one, that's equal to 1 by R square plus 1 by omega C the square. Am I right? That is a real part. I'll keep it outside. Okay. And one more 1 by omega C, that's also real. This minus J, I will take it in. This minus J, minus JR, minus J plus J, minus JR plus 1 by omega C into VI. Okay, fine. Can you see this one? Minus J plus J. Okay, fine. So that this is real, am I right? Some real quantity. And this is my complex quantity. What is this one? 1 by omega C minus JR. Fine. Into VI. VI, if you take VI real, this already real. Where is this one? That does matter. Am I right? Fine. I think that went to fourth quadrant. Am I right? Imaginary value, imaginary part is negative. That went to fourth quadrant. Okay. But they are not in phase. Okay. That's I'm sure. They are not in phase. Okay. Fine. V not. Now I can eliminate the option because they didn't give omega C or R value. Am I right? To find that. Isn't it? They didn't give those values. Okay, fine. Let me see the options. Okay, option. Okay, what is this one? First case, it must be 0. So then I can eliminate these two. Am I right? First circuit, there is no phase difference. Okay, option A or D. A also I can eliminate. Why? Second case, there is a phase difference. Okay, that I know. That phase difference is between 0 to pi by 2. I think 0 to minus pi by 2. I'm about to say like this. But he didn't say which one is leading, which one is lagging. Isn't it? He didn't quote that one. He just said phase difference, isn't it? That's why it's fine. 0 to plus pi by 2 or 0 to minus pi by 2. You got a point? But if I want to go accurately, okay. If I want to go accurately, what is this one? If this is my VI, okay, this V naught goes somewhere here. Am I right? V naught goes somewhere here. You got a point. This negative imaginary value. You just take VI and this real part. Okay. You club them together. Okay. Fine. So that phi, you got a point. That phi, tan of that phi, that's equal to what is it? Imaginary part minus R divided by 1 by omega C. Am I right? Like that. Okay. So check this out. But it is, we know that it is between 0 to minus pi by 2. Check this out. He said phase difference. Okay, he didn't say which one, how much V naught is leading or lagging. That he didn't ask. He just said phase difference. Okay, that's why that negative sign have no role here. Okay, can you grab this one? Okay, completely. Very simple. Okay. Now, this is the question. Very nice question. In the following RC network, for the input signal F is equal to 1 by 2 phi RC. F is equal to 1 by 2 phi RC means omega is equal to 2 phi into F. That's equal to 1 by RC. Am I right? Omega is 1 by RC. Then F will be 2 phi RC. Okay. He's asking voltage gain V naught by VI modulus. And the angle phase between V naught and VI. Okay. Phase difference between them. Okay. Fine. So one series RC, one parallel RC, they are connected in series. Okay. You just start solving this one. Okay. Parallel RC. Okay. Fine. R here, C here, R here, C here. Okay. This is my V now. You got a point? Now, obviously, again, I want to find total impedance of this arm. Okay. Wait a second. Yeah. I want to find total impedance of this arm. and total impedance of this arm. Can I redraw this one? Is that okay? Vi, so total impedance of this arm and total impedance of this arm. What do you say? I'll say this is Z1, this is Z2, okay? And I'm finding V naught here. You check that out, okay? You, while solving the problem, you build some other ideas, okay? Fine. So what is that Z1? Z1 is ZR plus ZC, am I right? Z1, okay? These two together, okay, that is Z1. Can I write directly? Okay. R minus J by omega C, okay? What is Z2? These two together, I'm writing Z2. Are you okay with this one? Okay, they are in parallel, am I right? Z2, 1 by Z2, am I right? 1 by Z2, that's equal to 1 by ZR plus 1 by ZC. Or we can write like this, Z2 is nothing but ZR, ZC divided by ZR plus ZC. Pick up. What is this ZR ZC? That's equal to minus JR by omega C divided by R minus J by omega C. You got my point? Then again, I'll apply that V naught, okay, output is nothing but voltage across this Z2. Again, potential divider formula. What is this one? Z2 divided by Z1 plus Z2 into Vi. Okay, and I need to work out this. Okay, fine. So now it's just a pure complex algebra. Okay, fine. Check, I mean, while solving the problem, if you get any other technique, but better to deal with general idea. Okay, what is this one? Z2. So we better to manipulate here only, am I right? We better to manipulate here only. Oh, actually, omega C equal to R actually, am I right? That if you use that one, this complex algebra will be more simple. Sorry, omega C equal to 1 by R. Can I use that one? It will be more quick actually. Wherever I have omega C, I should write it 1 by R, isn't it? That will be very quick complex algebra. Because he's asking at that frequency. Okay, fine. So that's why Z1 is 1 by omega C is R into 1 minus J. Am I right? So here 1 by omega C is R. Okay. Z2 minus J R square divided by R 1 minus J. What is this one? R minus J by 1 minus J. Can you quickly convert that one into R into minus J into 1 plus J divided by 1 minus J into 1 plus J is 2. 1 square plus 1 square. Okay, 2. Okay, that's equal to R by 2 minus 1 minus J. I made those complex numbers more simple so that I can quickly do the complex algebra. Is that right? Fine. So check the algebra. Okay, I'm doing quickly. Okay, Z2 is R by 2 1 minus J. Okay, Z1 is R1 minus J. Okay, fine. V naught. Okay, Z2 is R by 2 1 minus J. Okay, whole divided by Z1 is R into 1 minus J plus R by 2 into 1 minus J into Vi. Okay, fine. That's equal to R got cancelled. Okay. V naught. 1 minus J cancelled out. Okay. R by 2 divided by R plus R by 2 into Vi. Is that right? R got cancelled. Okay. V naught is equal to 1 by 2 divided by 3 by 2. Right? They are in phase. They are in phase. V naught by Vi mod is equal to 1 by 3. Okay, fine. So they will be in, they are in phase. You got a point. This is V naught is some plus 1 by 3 times Vi. If you take Vi along real axis, V naught also goes to real axis only, 1/3. Am I right? Can I say like this? If this is your Vi, okay, fine. V naught is 1/3 roughly. 1/3 and 0. Okay, you have the option. Okay, yeah, next one. So there are two questions of this kind. Okay, you can solve other question. Okay, I'll pick one of them. Okay, in JAM exam. Okay, so I think I told all gate aspirant you have to solve JAM question also for electronics. Electronics is electronics everywhere. Okay, there is no JAM electronics, gate electronics. Okay, see that one. Okay, some questions are very good, very nicely designed. Okay, for the AC circuit shown here in the figure, R equal to 100 kilo ohm, C equal to 10 picofarad. Okay, the phase difference between V in and V out is 90 degrees. They gave that one, but V out is not defined that easily. That is defined between A and V. You have to nicely handle the circuit. Okay, fine. At the input signal frequency of, okay, when, for what input frequency, phase difference between V in and this V out, V in and this V out, okay, that is 90 degree. That's the question. Okay, now you see this one. How do you do? Now it is not across any component, am I right? Earlier and all, it was across some component. We found voltage across that component in terms of main voltage. Now it is not across any one component, isn't it? Then how do you handle? So why can't you take one as ground? You can always do that in AC circuit also. Why not? Yeah. Here voltage drop is V in. Here also voltage drop is V in. Parallel. You see this one. V out is, okay, potential at A minus potential at B. If it is across C or across R, then we would have quickly written something. Am I right? You got it? This potential difference is known. Am I right? Or this potential difference is also known. They didn't ask directly across one of the component, any one of the component. They took this point and this point. They are asking V out is VB minus VA. But I'm saying you just check this out. I'll just pick one reference 0 volt. Fine, reference 0 volt. With respect to this one, this is becoming positive, negative, positive, negative. That's how it is. It is sinusoidal. Okay, I can think like it's always can be done. Okay, then V at A is nothing but VC. Potential at A is nothing but potential difference between A and then this ground. That's nothing but VC. What is it? V at A is equal to V at A minus 0. That's nothing but VC. Okay. V at B is nothing but V at B minus 0. Okay. This also ground. Am I right? You got it? That's nothing but V at R. This R. This R and this C. You got it? Then you just subtract them. Okay. Fine. Now, what is V at C? V at C, this C. What is that V at C? Speak up. That's equal to main voltage. Again, potential divider formula. This V in is divided across R and C, C and R. You got to find. This V in, it is divided across these two. Potential divider formula. Again, what is this one? ZC divided by ZR plus ZC into V in. That is our VC. Is that okay? And VR. What is VR here? VR. Again, main voltage is V in only because this is a parallel network. Okay, main voltage is still V in only. Okay, that is ZR divided by ZR plus ZC. Fine. Then what is this one? Next one. V out is VA minus VB. VA minus VB is nothing but VC minus VR, right? VC minus VR. So that's why V out is, okay, VC and VR are written. Okay, VC minus VR. Okay, ZC divided by ZR plus ZC. Okay, minus ZR divided by ZR plus ZC into V in. Something is missing. V in here. Okay, fine. Then, oh, easy only. Okay, what is this one? This is common, am I right? ZC minus ZR divided by ZC plus ZR. Can I say like this? Fine. That is into V in. Okay. ZC minus ZR is minus J by omega C minus R divided by minus J by omega C plus R, or minus R minus J by omega C divided by R minus J by omega C into V in. Fine. Minus R minus J by omega C. Okay. Multiplying and dividing by conjugate of denominator. I'll do that, but if I skip the step, then I may do the mistake. Okay, be careful. What is this one? R square plus 1 by omega C the square. Okay, multiplying by conjugate of this one, R plus J by omega C into V in. This real part, 1 by R square plus 1 by omega C the square. Okay, fine. Here, minus R square minus J plus 1 by omega C the square minus R square plus 1 by omega C the square. Next one is minus RJ minus RJ. I think minus 2RJ by omega C. Is that right? Speak up. Is this algebra right? Multiplication of this one, minus R square minus minus plus 1 by omega C the square minus R into this one, R into minus of this one, 2 times. Okay. Now he said, okay, output and input, okay, phase difference is just 90 degree. Okay, fine. You see this one, like if only this one exists, it will be 90 degree. How do you write J? E power I pi by 2? Including this is not making it 90 degree. Can you understand that one? Okay, with this one, this is A plus JB. I want just JB over there. You got it? In this term. This must be 0. Can you grab that logic? This must be 0. Then minus J will come. That you can write E power minus J pi by 2. Are you fine? What he said is, okay, V naught is equal to some real positive value, okay, multiplied with E power into E power J pi by 2 or plus or minus J pi by 2, I don't know, into V in. Any complex quantity, you should be able to write in this way. How, when you can write this in this way, when this quantity is 0, you got my logic. So that is, okay, that is R minus R square. What is this one? R is equal to 1 by omega C, am I right? R equal to 1 by omega C. I'll just keep this one. So R equal to 1 by omega C. What did he ask? He asked frequency, 1 by RC. Can you quickly do? F is equal to omega is equal to 2 pi into F. 2 pi into F. Okay, F is 1 by 2 pi RC. 1 by 2 pi. He gave 100K, 100 kilo ohm, I think 10 picofarad. Everything is in SI unit. 100K, 10 pico. Fine. Right in terms of kilohertz. Quickly, get me this one in terms of kilohertz. You have to keep the given condition in mind, okay? Output and input, they have 90 degree phase shift. Okay, 90-degree phase shift means you got to find. Like if you go with Argon representation, okay, it should be some R e power plus or minus j pi by 2. You got to find into V in. If you take V in along real axis, V out should go to either positive imaginary axis or negative imaginary axis. You got to find. So I mean, what is e power plus or minus either plus j or minus j, am I right? Only that should remain. That's why this must be 0. You got a point? This quantity must be 0. I'm saying the condition that they have given, output and input are having 90-degree phase difference. This complex quantity, it must be in this format. That's what I'm saying. E power plus or minus j pi by 2 is plus or minus j only, am I right? Cos pi by 2, I sin pi by 2. You got a point? That's what I'm saying. You got a point? You start with your very basic thing. When something was on the real axis, if you multiply with minus j or plus j, it will go to imaginary axis with 90-degree phase shift. Am I right? Your capacitor or inductor or something like that. Only j value should remain. If this also remain, then it will be a plus ib kind of thing. Then phase difference is between 0 to pi by 2 actually. Neither 0 nor pi by 2. You got to mind. If this quantity is non-zero, it is I think a plus ib or minus a minus ib kind of thing. Am I right? That kind of complex number. Then if you write tan phi, that phi will be between 0 to pi by 2. You got my logic? Pick up. I'm using all of those complex algebra and some trigonometry and all. You got it? Like this is one CSR net question. Okay. In the circuit shown below, the gain of the op amp, okay, in the middle of its bandwidth is 10 to the power 5. Okay, a sinusoidal voltage with angular frequency omega is applied in the input of the op amp. The phase difference between input and output voltage is. To find phase difference between input output, why I need that gain? I don't need that gain, I hope. To find the phase difference. Okay, fine. So can I say this is my Z1? This whole thing is my Z1. This is my Z2. Z1, ZF, am I right? ZF is simply R2. You got them? This is, what is this one? This is inverting amplifier. V0 by V in, that's equal to minus ZF by Z1. Okay, or V0 is equal to minus ZF by Z1. Okay, into V in. This whole thing together, I'm taking it as Z1. Okay, fine. V0, this is minus R2 divided by Z1 is nothing but R1 minus J by omega C into V in. You just carefully, okay, fine, work out this one. Fine. R2 is 4 kilo ohm. Omega is 100 radian per second. Okay, 100 radian per second. 100 into 5 micro. What is this one? Omega C. 100 radian per second. Everything is in SN. 100 into 5 micro. Can I say this is 0.5 micro? Okay, 100 10 to the power 2. Okay, 5 into 10 to the power minus 4 happened. I'll write 0.5 into millifarad. So that millikilo, that will get cancelled. Millikilo, you got it. And I need 1 by omega c, sorry. 1 by omega c, that's equal to 1 by 0.5. Or this is half actually, am I right? Half into 10 to the power minus 3 farad. Okay, 1 by omega c, that is 2 into 10 to the power 3. No, I should have done it later. Okay, those things. Okay, anyway, you try that one. Okay, that's equal to minus R2 divided by R1. I'm multiplying, dividing by conjugate of the denominator. R1 square plus 1 by omega c the square into R1 plus j by omega c divided by R1 plus j by omega c into V in. I don't need everything here. Okay, I don't need everything because he's asking only phase difference. You got okay? Any mistake? No, I mean multiplying. Oh, I already took the square. You got it. I already took the square here. Okay, find this one. Okay, so now that this positive real quantity, that doesn't matter. R1 square plus 1 by omega c the square. Okay, that doesn't matter. So what is this one? Minus R1 R2 minus j R2 by omega c. Is that right? Into V in. Into V in. Okay, that's equal to this positive real quantity. That doesn't matter. Okay, minus R1 R2. What is that one? Minus R1 R2. R1 R2 is 2k 4k. Okay, minus 8. So shall I do here only? 8 into 10 to the power 6. Okay, minus j into R2 is 4 into 10 to the power 3 divided by omega 1 by omega c is 2 into 10 to the power 3 again. Okay, this is the complex quantity into V in. Still, you can make algebra still better. Okay, fine. You got it. So that is what happened. Positive real minus 8 into 10 to the 8 into 10 to the power 6 outside minus 1 minus j into V in. That positive real part, that doesn't matter. Am I right? Can I say like this? This 8 also I will absorb here. These are positive real part. Okay, minus 1 minus j, isn't it? Into V in, V naught. Where is here? Where is this one? This is in the third quadrant. First, second, third quadrant. Okay, fine. How do you write this one? Minus 1 minus j. Third quadrant, I think 5 by 4 or 5 pi by 4. Now look at here. So whenever I'm handling this one, I don't use much trigonometry. I'll use my logic here. You got it? In my mind. Okay. So this is imaginary axis. Okay. This is real axis. Okay. Now, what is the, if you compare it with A plus IB, am I right? A plus IB, that real part and imaginary, that components are same. I'm seeing complex number as a vector. It is making same angle with real and imaginary part, real and imaginary axis. You got my logic? It is in this quadrant. It is making same angle actually, 45 degree, 45 degree. Now what is that one? That is 5 pi by 4, 5 by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, 5 pi by 4. That is 5 pi by 4. This one. You got a point. So check this out. Root 2 e power I 5 pi by 4. Or minus 3 pi by 1 pi by 4, 2 pi by 4, 3 pi, minus 3 pi by 4 also works. Fine. This vector, this complex vector that makes that have same projection along real and imaginary. Can you see? Minus 1, minus 1. Real part is also minus 1, imaginary part is also minus 1. Okay. Like that I quickly judge without doing trigonometry. Okay, fine. See that one. Is that okay? A low pass filter is formed by a resistor R and capacitor C. At high frequency, it will act like a short. High frequency, it will act like a short, output is 0. High frequency is rejected. Low frequency, it will act like open. Okay, fine. So V naught here. Okay, fine. V in here. R say. At the cutoff frequency omega c equal to 1 by RC, the voltage gain and the phase of the input, phase of the output voltage relative to input. Okay, fine. I hope you know in that low pass filter, isn't it? In that low pass filter, okay, fine. What is that? If you write V naught, okay, versus frequency, what will happen? At low frequency, I think V naught is same as V in. Their peak value, okay, their peak values are compared. Phase difference will be there. Okay, fine. Or gain will be 1 at low frequency. High frequency will be rejected. Am I right? Somewhere here, I think, what is that? Your cutoff frequency comes, FC. Can you recall? That is 1 by root 2 times this one. Okay, 1 by root 2 kind of thing. Okay, fine. These things. Okay. You should know that at cutoff frequency, voltage gain is 1 by root 2. Can you recall? Or we used to draw gain versus frequency. Low pass filter. Gain is 1 here. This is 1 by root 2. You got it? That will give FC. Okay, fine. That's again that FC is nothing but 1 by 2 pi RC, or omega C is nothing but 1 by RC. You got it? The same thing. Okay, fine. So then the two options can be that 1 by 2 means 0.71 or something. 1 by root 2. Is that right? Then next thing is, okay, a phase difference. Okay. V naught by V in, that's equal to, or V naught is equal to, what is this one? ZC divided by ZR plus ZC V in. Okay, fine. So have go with a very fundamental approach. Okay, minus J by omega C R minus J by omega C V in. Okay, so this omega is equal to omega C, that's equal to 1 by RC. Omega C into C is nothing but 1 by R. So that's why this minus J into R minus J into R. You got a point? 1 by omega C is R. Okay, fine. V naught. Okay, V in here. Okay, R got cancelled. Minus J, 1 minus J, V in. V naught is equal to minus J into 1 plus J divided by 1 square plus 1 square. V in. 1 minus J by 2 into V in. Right?
So fourth quadrant minus 45 degree.
It is in the fourth quadrant. Minus 45 degree. Fourth quadrant is minus 45 degree. You can write like this. Okay, fine. So that's quick. Okay, 1 minus J. You just have to look into 1 minus J. All positive real part doesn't matter. Okay, you got it. If V in is here, your V naught, it will be in the fourth quadrant. Okay, with what is this one? Minus 45 degree. You got a point. It is having positive real component, negative imaginary component. Okay, like that. Okay, and mod of V naught by Vi. Okay, what is this one? Mod of 1 minus J divided by mod of 2. Isn't it? What is this one? That is mod of 1 minus J root 2 divided by 2. That is 1 by root 2. That's what I remembered actually. Okay, that's how we define cutoff frequency. Cutoff frequency is that frequency where our gain dropped by 1 by root 2 of its original value, maximum value, or output voltage dropped by 1 by root 2 of its maximum value. Okay, half power frequency. Why? It will deliver half of the maximum power. Okay, at that frequency. Okay, half power frequency. Fine. That I remembered, but if you wish, you can do that one. Here only you can do the gain also. Okay, fine. Yeah, this is gate problem. Okay. Can you check this out? Input voltage is 2 cosine of 100t. V in is 2 cosine of 100t. Output voltage is 2 cosine of 100t minus pi by 2. Value of C is. Phase difference is known. Should we do full analysis? I'm thinking like, you got to find. Finding V plus V minus nearly equal to writing V out in terms of V in. No, V in is it's a kind of differential amplifier, okay? You got to find. It's not like one of them is grounded, other one is given input, okay? So I think it may take time. You try to like generate any other idea. This is one low pass filter, am I right? V in here, RC here, okay? V not here, okay? Find V minus, find V plus, equate them, okay? V plus is nothing but V plus minus ground, that's nothing but VC. VC is not again potential divider formula, you got to find. V in is here. Potential divider formula, what is VC? ZC divided by ZR plus ZC into V in, okay, fine. So that's why V plus is ZC by ZR plus ZC into V in. Or you just do that one, okay? V in R here, okay? One more R here, okay? V naught, V in here, V naught here. Find the current, okay? Assuming current is flowing like this, what is this one? RR, okay? Current is nothing but higher minus lower, V in minus V naught divided by 2R. Okay, I need this one, am I right? V minus here. I need this one. Okay, fine. V in minus V minus, that's equal to I into R. I is V in minus V naught divided by 2R into R. There was some quick way, no quick way to find that one. Just check the slides once, okay? Fine. In the flow, what I have done during the class, okay? Now I need V minus here, am I right? That's what I was saying. Okay, this V in minus V minus, that's a potential drop across one of the resistance. That is half of the total potential difference. You got to find V in minus V naught by 2. Are you understanding my point? That V in minus V naught, that potential difference, that is half of that one is dropping across each of them. Again, potential divider kind of. Okay, anyway. Now V minus, that's equal to V in minus of V in minus V naught by 2. Okay, fine. V in minus V naught by 2, that is V in by 2 plus V naught by 2. Check the algebra quickly. Now V plus nearly equal to V minus. ZC by ZR plus ZC into V in, that's equal to V in by 2 plus V naught by. Is that algebra right? Yeah. Then if I take V in here or V naught by 2, that's equal to V in here, V in outside, ZC by ZR plus ZC minus half into V in. Am I right? following circuit, okay, again low pass filter. For the circuit, frequency above which gain will decrease by 20 decibel per decade. It's a knowledge based question, or you can even do that one, but not required. What is that one? That is a cutoff frequency. You got to find. So that roll off, you got to find. First order filter. Can you go through that one, that roll off decibel idea? Because I found 2-3 questions in GATE exam. Okay, regarding that one. Okay. So low pass filter, am I right? Low pass filter. Okay. It will roll off here. Okay. Actually, this is supposed gain RF by R1. Am I right? Gain is 1 actually. Fine. Highest gain is 1. You got it. This is not producing any extra gain. Okay. Fine. So, or I'll write A maximum. Okay. Maximum gain. Okay. Maximum gain by root 2 actually. AM by root 2. From here to here, how much decibel decrease? Any idea? 3 decibel. Okay. That also one more knowledge based question somewhere. I'm saying after this one, okay, it started from here to here, it was having a kind of change in slope actually. You got it. But after this one, its slope is nearly fixed actually, minus 20 decibel per decade. You got it. You have to spend some time on this one, okay, this particular one, okay, decibel per decade, those things, okay. Questions are there. In CSR net exam, they asked one very tricky question on the decibel idea, comparing two voltages, okay. Anyway, you got a point. So that is, what is this one? This is nothing but our FC. I think that is 1 by 2 pi RC only, am I right? First order filter. Okay, can you quickly do that one? 1 by 2 pi, R is 10K, 1000 pico. Can you quickly write, get me this one, quickly?
15.9 kilohertz.
15.9 kilohertz, okay. 15.9 kilohertz, okay, fine. So check this out. And I mean, earlier they used to ask 2 questions on one input, okay, fine. So this is the second question. What is this one? At 1.2 kilohertz, what is the closed loop gain? You got a point. What is the closed loop gain at 1.2 kilohertz? Oh, I should not have done this much. Can you tell me why? That is the gate problem. If 15.9 is that cutoff frequency, at 1.2 kilohertz, you have full, what you call, gain, am I right? You got a point. That means that filter is completely passing. Filter have no role now. Only gain is decided by 3 by 2. You evaluate that. You got a point. Now this filter have gain 1. This filter circuit have gain 1. You got a point. Now only op amp gain will play the role. That is 3 by 2. You got a point. For just RC filter also we used to define gain. In the complete pass region, gain was 1 actually, am I right? You see 1.2 kilo. First part is solved, am I right? 15.9 kilohertz. And he's asking what is the gain in 1.2 kilohertz. This should not be done. 1.2 kilohertz, okay, this gain is unity. And only gain is decided by this one. You got him? At that one, this is 1 actually. In the pass band, this was 1. You just check this out. Okay, gain is decided by this one, 3 by 2, 1.5. You got my point? No, the thing is like old suggestions won't work for recent GATE exam. They made some question lengthy also in the recent GATE exam. You got a point. Earlier I used to say that if question goes lengthy, then you are thinking in a wrong way. But not for recent question actually. Okay, fine. But anyway, if you feel like, okay, whatever your approach, that is too much time consuming, you keep it for late. And that you can't directly exhibit in the exam hall, you practice in the practice test. You got a point. If you think that goes lengthy, then you keep it later. You got a point. No easy question should be left in the paper. Okay, fine. Practice that one. Okay, that's not so easy. Yeah, I'll try. Okay, I'm not sure about today's practice test. Okay, but I'll post definitely on Monday. Tomorrow you have to take NPTEL practice test. Fine. Tomorrow take NPTEL practice test. Okay. 2 to 5 only, right? They're conducting 2 to 5 only. Tomorrow take NPTEL practice test. One more practice test is ready, but I need to check again. Small mistakes will be there otherwise. Okay, fine. I'll check and update. Okay, Monday.
So in the last question, since the gain is 1, this V minus is V minus equal to V in, right?
No. Wait. I'm saying this is completely passing. This gain is 1. But once you feed here, this is one non-inverting amplifier. 1 plus 1 by 2 will be there.
Yeah, that I understood. Like what I'm asking means this V in like V minus is nothing but V in.
Yeah,
Since
exactly. Yeah, V minus is nearly equal to V. Perfectly. Peak value, phase difference will be there. Okay, fine. You got a point. V out peak value. Is that okay? Fine.